Okay, hello everyone. In this video we are going to discuss about Fourier sine and cosine transform of derivatives. First we are going to discuss about Fourier sine transform of derivative, then we are going to discuss Fourier cosine transform of derivative. Okay, so let's start. We know that we know that in general the Fourier sine transform of a given function suppose ft is the given function, is written as like this: Fourier sine transform applied over the function f of t will be equal to, in general it is written as 2 by pi root over 0 to infinity that function, given function, into sine omega t into dt, that we know. Okay, now we are going to consider the first derivative of this function and we are going to apply the Fourier sine transform over that. Then what we are going to write? If we consider f dash t and then Fourier sine transform of f dash t will be Fourier sine transform is applied over first derivative of that function will be written as 2 by pi root over 0 to infinity first derivative of that function into sine omega t into dt. Okay, so these things will be how much, that we are going to be find out. Okay, so here you can see that we have two functions in this integral. This is your one function, this is another function. So here two functions means we are going to be consider the integration of by parts. Okay, for by parts we know that we have to apply this one. So inverse logarithm, I let inverse logarithmic, arithmetic, trigonometric and exponential for choose the first function, right? Here you can see that here one unknown function is there. Unknown function ft is what we do not know, but this is your trigonometric function. So inverse logarithmic, arithmetic and trigonometric. So here trigonometric function is known, but as this function is unknown, so here we consider that sine omega t is your first function and this one is your second function. Okay, so if we are going to take its integration, then it's easily that derivative will be removed. Okay, so we are going to write accordingly. So that implies Fourier sine transform applied over first derivative of a function, that is your f dash t will be equal to 2 by pi root over, okay, 2 by pi root over. So this one is your first function, so sine omega t into 0 to infinity integration of ft dt. Okay, then minus integration of 0 to infinity derivative of first function with respect to t, then again integration of second function f dash t, with respect to t, and again whole integration dt, close the bracket. Okay, here you can omit the step in your exam, but write in your note all the things. Okay, so is equal to 2 by pi root over sin omega t. Here derivative is there, integration we are going to consider means only ft, limit will be 0 to infinity. Okay, minus here sin omega t derivative will be omega into cos omega t, and integration of this one will be ft dt. Okay, now that implies Fourier sine transform of first derivative of a function ft will be equal to what we are going to write. See, 2 by pi root over is there. Here you can see we have to put the limit infinite. So here sine infinite into f of infinite minus, I am going to write it will better, sine infinite into f of infinite minus sine 0 into f of 0. Okay, then this will be minus omega 0 to infinity, omega taken outside, cos, I can write in this way, it will better, f of t into cos omega t dt. Okay, what I done, taken this omega is constant, taken outside of the integration, and ft I written first, then cos omega t. Okay, so here you can see that f of infinite, that means function value at infinite will be 0. Why? Because in case of Fourier transform or Fourier sine or cosine transform, here any function ft or fx or any function is considered as a signal. Okay, a signal which will be propagated from one place to another place. So at infinite, the signal or the wave will be at infinite will be 0 value, because we are going to consider its attenuation if it will be propagated from one station to another station. So at infinite the signal will be 0, because it's due to attenuation, its amplitude will be gradually decreases. So hence at infinite there is no signal we are going to get, so f of infinite will be 0. So that implies if this term will be 0 and this term also will be 0, because sine 0 will be 0, so entire this term will be 0. So finally we found that implies Fourier sine transform of the first derivative of a function ft will be equal to 2 by pi root over. Okay, here you can see 2 by pi root over, this term will be 0, this will be minus omega is there, integration of 0 to infinity ft cos omega t into dt, right? That implies Fourier sine transform of a first derivative of a function ft will be equal to, here you can see, minus omega into 2 by pi root over 0 to infinite integration ft into cos omega t dt. So this value is nothing but, this one is nothing but Fourier cosine transform applied over the function ft, right? So same thing you have to write. So that implies we found Fourier sine transform of a first derivative of a function will be equal to minus omega into Fourier cosine transform of that function. Okay, okay, next we are going to move to find out the Fourier transform of double derivative of that function. Okay, now Now consider, see this expression you have to remember, it will be useful whenever we are going to discuss application of Fourier transforms. Okay, so now consider Fourier sine transform of double derivative of function ft will be equal to what we are going to write. We are going to write as similar fashion this one. Fourier transform of ft in general will be written this one. So instead of ft here, double dash ft is there. So what we are going to write, that will be 2 by pi root over 0 to infinity f double dash t into sine omega t into dt. Okay, now for this integration, this will be considered as second function, this will be considered as first function, because as this is an unknown function, so here this one will be considered as the first function. So whenever we are going to do the integration, then easily this derivative will be removed. So that implies f dash, sorry, fs Fourier sine transform of double derivative of this function ft will be written as 2 by pi root over. Now we are going to consider the by parts. Okay, this is the first function, and then integration of this one, directly I am writing integration of this one will be f dash t, because double dash is there, so integration with respect to t, one dash will be removed, 0 to infinite. Okay, then minus derivative of this one, integration of this one, derivative of sine omega t will be, first I have to write 0 to infinity, derivative of this one is your omega into cos omega t into integration of f double dash t with respect to t will be f dash t into dt, right? Okay, put the bracket, whole bracket. So that implies Fourier sine transform of double dash t will be equal to, here you can see 2 by pi is there, you just write it. Now here you can see that whenever we are going to apply or going to put the higher limit, then it will be sine infinite into f dash infinite. You just write sine infinite into f dash infinite minus sine 0 into f dash 0. Okay, 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 then this is your minus omega 0 to infinite, 0 to infinite cos omega t f dash t into dt. Okay, cos omega t f dash t into dt. Again, that implies Fourier sine transform of double derivative of function ft equal to 2 by pi root over, here you can see that f dash infinite. See, as I told that the function ft in case of your Fourier transform or Fourier cosine transform or Fourier transform itself, sine transform itself, this function is considered is a signal. So signal means sinusoidal wave, that wave is fully continuous, that means at each and every place it is continuous. Okay, if it is continuous, then obviously it's f dash t, first derivative will be continuous everywhere. So as this signal ft at t tends to infinite, the ft equal to 0, obviously as this function is continuous, then t tends to infinity, f dash t will be f dash 0, sorry, f dash infinite will be also equal to 0. Okay, so you just write over here, here you just write, okay, this value we have been considered as 0. So at this after this line you just write, if sorry for uh, t tends to infinite, for t tends to infinite, ft will be equal to 0. You just put mod t, that means either t positive, plus infinite or minus infinite. So at minus infinite the function not to be found, at plus infinite the function not to be found. Okay, so hence ft equal to 0 for t tends to infinite. So only for that we consider this term will be 0. Okay, now similarly here f dash infinite also will be 0, because as it is a sinusoidal or signal, then obviously it will be continuous and first derivative will be continuous, hence f dash infinite will be 0. And here sin 0 obviously is 0, so this entire term will be 0. So you just write 0 minus omega. Here again we are going to consider the by parts of this one. Next step we are going to do that, 0 to infinity cos omega t into f dash t into dt. Okay, here you write that for t mod tends to infinite, f dash t equal to 0, right? Now our work is to find out this integral by considering by parts. So for the by parts, obviously this will be considered as the second function and this one is your first function. So that implies f dash, sorry, for your sine transform of f double dash t will be equal to 2 by pi root over, here minus omega is there, just write it, and here again we are going to consider the by parts. So this will be the first function, this will be the first function cos omega t into and this is the second function, integration of the second function will be ft and its limit will be 0 to infinite, then minus the derivative of cos omega t and integration of this one we are going to consider the derivative of this one cos omega t is your minus of omega sin omega t, because cos omega t derivative is minus sin omega t and omega is there, so minus omega sin omega t into f of t, okay, into f of t, and here integration is there, f of t dt, and obviously integration will be there 0 to infinite. Okay, put it inside the bracket. So here we found that Fourier sine transform of double derivative of the function ft will be equal to, see here if I will put the limit, here you can see that f of infinite, if I will put f of infinite, you just write it will better, 2 by pi root over minus omega, okay, cos omega t in, sorry, cos omega infinite means cos infinite into f of infinite, then minus 0 we have to put, cos 0 into f of 0, then this is your minus plus omega 0 to infinite f of t into, here f of t I written first, into sin omega t into dt. Okay, so here interestingly you can see that this term will be 0 because f of infinite will be 0, but this term will be not 0 because f of 0 not to be 0 and f cos 0 will be 1. Okay, So what we found, we have to write in the next page that Fourier sine transform, that implies Fourier sine transform of double derivative of a function will be equal to 2 by pi is there, 2 by pi minus omega is there. So you just write 2 by pi root over, 2 by pi root over minus omega. Okay, then other terms we have to write here. This first term will be 0 because f of infinite will be 0, means this first term will be 0. The second term will be cos 0 will be 1, and this will minus f of 0. Okay, so minus f of 0 will be there. So here it is written minus f of 0. Then next term is your plus omega 0 to infinity f of t sin omega t dt. Same thing you have to write plus omega integration 0 to infinite f of t into sin omega t into dt, right? Put the bracket. Okay, now we are going to multiply this term with this one and this one. So that implies Fourier sine transform of f double dash t will be equal to, here you can see this minus minus will be plus, so 2 by pi root over omega into f of 0 plus, no, not plus, here minus, here plus is there, so obviously this will be minus omega square into 2 by pi root over is there, integration of 0 to infinity f of t into sin omega t into dt. Okay, so here you can see that this is nothing but Fourier sine transform of this one. That means we can write f of s of Fourier sine transform of ft, right? So finally what we found, that implies Fourier sine transform for double derivative of a function will be equal to this one, 2 by pi root over into omega into f of 0 minus omega square into Fourier sine transform of this function f of t, or you just write, okay, or it will written as Fourier sine transform of double derivative of that function will be equal to 2 by pi root over omega f of 0 minus omega square, this will be written as capital Fs omega. Okay, so I suggest that you just remember this one, that double derivative Fourier sine transform of a double derivative of a function will be this one, because this expression is very much essential whenever we are going to solve the applications part of the Fourier transform. Okay, so here also you can write this one as equal to minus omega Fourier cosine transform of ft or capital Fc omega. Okay, so also I suggest that you just remember this one also, where is my, this expression. Okay, this expression you just remember, this is also essential whenever we are going to discuss the application part of the Fourier transform. So here we have to stop our discussion. In our next class we are going to discuss Fourier cosine transform of derivative. Okay, here another thing I want to suggest to all of you, that in this video we have been evaluated Fourier sine transform of derivative for first order derivative and second order derivative. But suppose in your exam it is asked that you have to evaluate Fourier sine transform of third order derivative or fourth order derivative of a function or any higher order, then you have to follow the same procedure whatever we have been discussed in this video. Okay, and what you have to do, the extra things means you have to do the bypass some extra times. That means for first order derivative one bypass we done, For second order 2 times we done the by parts. For third order you have to do 3 times. For fourth order you have to do 4 times. Okay, so as per your BSc syllabus, up to second order is enough, and up to this much also is enough for your exam point of view. And whenever we are going to discuss the application part of the Fourier transform, also up to this much is enough. But suppose in your exam it is asked higher order, suppose order or fourth order derivative for Fourier sine transform of third and fourth order, or any higher order, you have to follow the same procedure. Okay, so thank you so much for watching this video. Thank you.